Okay. Hi, who is online? Network is too bad. If you're online, just say hi. If you're online, say hi. Let's know who is online so that we can start. The weather is not bright. Hi, welcome to today's class. Who is online? Yes, if you're online, say hi. So we can start. Okay, have Osako Okechukwu, you're welcome. You're welcome, you're welcome. Okorafo Maria, you're welcome. Ephraim George, you're welcome. Please double tap on your screen. Double tap on your screen. Lozon Kenneth, hi, you're welcome. You're welcome. Hello, good evening. Welcome to today's class. Okay, so today I'm going to look at some calculations on electrolysis. So we're looking at electrolysis calculations. Okay. Mozafus, hi, you're welcome. Read the pitch, hi, you're welcome. All right. Let us look at this simple example on electrolysis. And yesterday we were able to state Faraday's law, and we derived a relationship from Faraday's first law of electrolysis. Now the mass deposited during the process of electrolysis is directly proportional to the quantity of charge which has passed through it. So going by that, we prove that M is equal to ZIT, right? So I'm going to use this formula to solve our what? Our question. All right. Okay, let's solve. I believe you can hear me. All right. Find the mass of copper deposited on the cathode of a cathode voltameter if a current of 0.53 amperes is passed through it for 30 minutes. And from the question, we are giving electrochemical equivalent. Electrochemical equivalent to be 3.3 times 10 raised to the power of minus 4 grams per coulombs. All right. Now, for us to be able to solve the mass, we are going to state our parameters given by saying the mass is what you are looking for. We are given a current at 0.53 amperes, and we are giving time. The time is 30 minutes. So we have electrochemical equivalent, that is it. The electrochemical equivalent is given as 3.3 times 10 to the power of minus 4. Okay? Now, we have this T. What you're going to do is to convert this time to seconds. You must convert it to seconds by saying that T is equal to 30 times 60. Okay? Because 60 seconds makes 1 minute. And then we have 30 minutes here. We are going to multiply this 30 minutes by 60. It's going to give me what? 1,800 seconds. All right. Now from our formula, we have that M is equals to ZI what? IT. What is my Z? My Z is electrochemical equivalent, which is 3.3 times 10 to the power of minus 4. Okay? Times my current I is 0.53 times the time, which is 1,800. Okay? So with the help of your calculator, you multiply 3.3 exponent minus 4 times 0.53 times 1,800. So my answer is going to give me 0.315 grams. Now the question is, why do I have grams instead of kilograms? My concentration is in this Z, which my electrochemical equivalent. For the fact that this electrochemical equivalent is given in grams, my mass will be in grams. But if it is given in kilograms, my mass will be in kilograms. Do you understand my explanation? All right. Please double tap on your screen, okay? If you are just joining us, give it a thumbs up and double tap on your screen. Agiken, you're welcome. Please copy what is on the board. All right, do we understand what I just explained? If you do, copy it and let's proceed. Now, can we proceed? Calio, you're welcome. Please, can you hear me? The weather is not bright. Can you hear me? All right. You can hear me. Then let's look into the second example. The question says, in an electrolysis experiment, a metal of mass 5 kilograms is found to weigh 5.01 grams. Okay? After a current of 5 amperes plus for 50 seconds. What is the electrochemical equivalent of the substance deposited? Let me do a recap. In an electrolysis experiment, a atom of mass 5 kilograms, 5 grams rather, is found to weigh 5.01 grams after a current of 5 amperes plus for 50 seconds. What is the electrochemical equivalent of the substance deposited? For us to solve this problem, we have different masses, okay? We have the first mass and we have the second mass. So what we're going to do is to subtract the two masses together, okay? Now let's go. M4 equals to 5 grams. And 5.01 grams. Now current is 5 amperes. And time is 50 seconds. So we are looking for C. What you're going to do now is to find the difference in mass. I would say change the mass. That is X2 minus M1. Okay? So we have 50.01 minus 5. We have 5.01 minus 5 is going to give me 0.01 grams. Okay? Now I'll use my formula. This says that first, mass is equal to ZIT. I am looking for Z. So I'm going to divide both sides by IT. Okay? So Z is equal to what? Mass over current times time. Right? My mass, I've already got it to 0.01. 0.01 divided by my current is 5 amperes times my time is 50. Okay? So what I'm going to do next is I'm saying C is equal to 0.01 over 5 times 50 is what? 250. Then I'll use my calculator to divide 0.01 divided by 250. So my answer becomes 0.01 divided by 250. My answer becomes 4 times 10 raised to the minus 5. I will have grams per column. Now this is how we can get the electrochemical equivalent of the substance deposited. Let me go back again. We are given two different masses. So what we are going to give this one is to find the difference in the masses by saying that change in mass is equal to N2 minus M1. Okay, that is 5.01 minus 5. It's going to give us 0.01 as my mass. Then from the Faraday's law, the mass is equal to ZIT. And I'm looking for Z. So I'm going to divide both sides by current and time. I will have this. I will substitute in my values. My mass is already given as 0.01. Then divided by 250. And my answer is equal to 4 times 10 raised to the minus 5 grams per product. I don't know if you understand this particular example. Please, do we understand what I just said? Do we understand? All right, if you understand, tell it to Kalio, then put it down. And copy it and put it down. Are we done writing? Are we done writing? I copy your question first so that we can solve? Are we done so I can solve? Are we done writing? All right. This question says, when a current of 10 amperes, 10 amperes flows in an electrolyte for 3 hours, a mass of 1.0 gram is deposited. What mass will be deposited in 10 hours, 10.0 hours, if a current of 3 amperes flows through the electrolyte? Hope you get the question. When a current of 1.0 amperes flows in an electrolyte for 3 hours, a mass of 1.0 gram is deposited. What mass will be deposited in 10.0 hours if a current of 3.0 amperes flows through the electrolyte? Now, in this question, what we are going to do is to state our parameters. We have two different currents. We have this current, we have the rest, we have the time, and we have what? We have the mass, right? Now we are asked to find the second mass, and the second time is 10 hours, and the current is 3 amperes. See how we can solve it by saying I. That is the first current is given as 1.0 amperes. Okay? The first time is given as 3 hours. Then my first mass is given as 1.0 grams. Okay? I'm looking for the second mass. That is N2. That is what I'm looking for. Okay? My second time, see, is 10 hours. And my second current is 3 amperes. Now you're going to do comparison. Comparing this and another one. What do I mean? This is the first parameters given. This is the second parameters given. They have the same electrochemical equivalent by saying M is equal to ZIT, right? Now, if I make Z the subject, I have Z is equal to N over what? IT. Alright? Now, if I'm comparing it with another one, what am I going to do? This is M1, I1, and T1, right? It's now equal to M2 over I2 can decide to overlook it. This is my T1, this is my T2. So let me substitute what I have. Find your note. What's my M1? My M1 is 1. Okay? Over. My I1 is 1. Plus my T1 is what? 3. Then is equals to my M2 is unknown. Right? My I2 is 3. Right? And my T2 is 10. I will say times 10, right? Now, what I'm going to do is to say cross multiply. If I say cross multiply, although this is going to give me 3, so I'm going to have 1 over 1 times 3 is 3 is equals to m over 3 times 10 is 30. Okay? Now if you cross what? Multiply. If I do cross multiply, I will have m times 3 give me 3 words. M is equals to 1 times 30 to give me 30. Right? So I'm going to divide both sides by what? By 3. Alright. So my mass okay, I wrote T1 instead of T2. Tell where? Where did I do that? All right. Now let me explain. I have different currents, time, and grams, right? So what I need is to compare them. I'm supposed to convert this time to seconds, but because they have the same units, I can set units like that. Now I'll compare from this m is equal to z. Alright, sorry, my network is wrong. So when I compare them, I will have this. My first mass given as 1, that is what I have, divided by my first current is 1, my first time is 3, right? Then I'm looking for my second mass, my second current is 3, and my second time is 10, okay? So I work it out, this is 1 over 1 times 3 is 3, while this is x2, 3 times 10 is 30, right? I do cross multiply. I want I do. If I do cross multiply, okay, m2 times 3, that is 3m2, 1 times 30, that is 30. I divide both sides by the coefficient of m2, which is not 3. When I divide, I'm going to have what? 10 grams. Do you understand? Please, if you are just joining us, double tap on your screen, please. Please, if you are joining. Okay, yes, Grace. I just used the parameters we derived yesterday to solve problems. Okay? Using the Faraday's first law. I'm just using it to solve problems. So today we are solving problems on electrolysis. Right? You can still get the beginning. Maybe it will be after the what? After the class. I'm going to send it on the group so I can watch it. All right, so you can just copy what you have on the board because we want to solve more problems. Please like this class, double tap on your screen, and make sure you subscribe to this channel. Are we guys done? Are we done? Are we done? All right, let's proceed. Copy your question. Let's solve together. ECE is electrochemical equivalent. And that is the short form of Z. Electrochemical equivalent. Are we done writing? Let's solve together. Okay, we are done. All right. Example 4. During the electrolysis of a two central atoms of a fixed solution, an ammeter shows a steady current reading of 1.0 amperes for 30 minutes, while 6.6 entails per minus 1 kilogram of copper was liberated. Calculate the error in this ammeter reading. This is different from what you have been solving. We are giving the current of 1 ampere, then we have time of 30 minutes. Electrochemical equivalent is given, and we have mass. The question says we should calculate the error in the current reading, in the ammeter reading rather. That means we already have our current. Let's get our new current to be able to find the error. So the first thing is for us to state our parameters. So let's go. The current is 1 ampere. The first current. The time is 30 minutes. We are going to convert this time to seconds. We are multiplying by 60. Okay? Now the mass is giving us 6.6 times 10 to the minus 4. Then the electrochemical equivalent is giving us 1. So you can subtract to get the error. my time? My time is 1,800. So let's work it out by saying hello, Jacob. Thank you so much for coming. I really appreciate. All right. Grace. Okay, Grace, we did not convert the previous question. Did not convert the time to seconds. And I explained why. I said that the time is supposed to be in seconds. But since the both time are given in hours, you might not need to convert because the units are the same. Even if you still convert it to seconds, we are still going to work it out and cancel the seconds, which is the same thing as not converting the what? The time. They are not actually looking for time. That was why I did not convert. And we have the different times that varies. And both of them are given in hours. So there is no point changing it to seconds. Do we understand? All right. Now, what I'm going to do is to work on this to have 6 times 6 times 10 raised to a minus 4, then divided by, I'm going to work it out to see what I have. Using my calculator, I will say 3.3 exponent minus 7 times 1,800. So I'm going to have 5.94 times 10 raised to the power of minus 4, right? So what I'm going to do now is to divide to get the answer of the current. So let me divide 6.6 exponent minus 4 divided by 5.94 exponent minus 4. Okay, my answer is what? 1.111. Now we have gotten 1.11 amperes. But what we are asked to find is to find the error. The error in the ammeter reading. What is the error? I was given the first ammeter to be what? To be 1 amperes. And I've got this one to be my second ammeter. And I've gotten it to be 1.11 amperes. So for me to get the error, I'm going to find the difference by saying the error is equals to I2 minus I1, right? That is 1.11 minus 1.0, okay? So when I subtract, I'm going to have 0.11 amperes. Now this becomes the error in the ammeter reading. Do we understand? Okay. Okay, so Z is electrochemical equivalent. Victory, you're welcome. Double tap on your screen and give it a thumbs up. Thank you for coming. Please, do you understand what I just solved? Do you understand what I just solved? Maria, your calculator gave you 1.1 times 10 to the power minus 6. Okay? You're going to work on your calculator, work on your powers. Work on your powers. Work on your powers and see where the mistake is coming from. It's not supposed to give you that for minus 6. Okay? Work on your powers and do it again. Ephraim, so I should explain again. All right, let me explain. All right, this question goes this way. During the electrolysis of copper 2 tetraoxosulfate 6 solution, an ammeter shows a steady current reading of 1.0 amperes for 30 minutes, while 6.6 times 10 to the minus 4 kilogram of copper is liberated. Okay? Calculate the error in the ammeter reading. And we are giving electrochemical equivalent. This is electrochemical equivalent. It's giving us 3.3 times 10 to the power of minus 7 kilograms per coulomb. Now, the first thing I'm going to do is that I have a steady current from the question. And the question says there is an error in the ammeter reading. So we need to get an error in the ammeter reading. This is not supposed to have a steady current. But the current was steady, it was not moving. So for us to get the ammeter reading, the error in the ammeter reading, we are going to use these parameters given to get the new current. Now, if you're able to get the new current, you can then subtract it from the steady current, okay, to get the error in the ammeter reading. Now, for us to do that, I tag this first current to be my I1, okay? Then my time is 30 minutes. And I'm going to convert this minutes to seconds by multiplying by 60. And it gave me 1,800 seconds, okay? Then the mass given is given as 6.6 times 10 to the power of minus 4 kilograms. Now, the Z, which is the electrochemical equivalent, is 3.30 times 10 to the power of minus 7 kilograms per coulomb. So the first thing we are going to do is to remember Faraday's first law. Okay? Faraday's first law states that what? The mass is equal to ZIT. M is mass, Z is electrochemical equivalent, I is current, and T is time. Now I am looking for the new current so I can be able to get the error. So I made it the subject by dividing both sides by ZT. So M is I2 is equal to M over ZT. Right? Now, substituting into what I have. My M given is 6.6 times 10 to the power minus 4. So I have it divided by my Z is 3.3 times 10 to the power minus 7. Then times my time, which I got to be 1,800. All right. So I brought this down and I multiplied the denominator. I got 5.94 times 10 to the power of minus 4. Okay? Then I have to divide to get my I2. And my answer gave me 1.11 amperes. But we are not yet done because they are asked to find the error in the ammeter reading. Now, how do we get the error in the ammeter reading? For us to get the error in the ammeter reading, the error becomes the new current minus the steady current. That's I2 minus I1, okay? And I have 1.11 minus 1.0. So my answer becomes 0.11 amperes. I hope it's all clear. All right, yeah, I've gotten it now. It was a mistake. Okay, that's good. Ephraim, Judge, have you gotten it? Thank you so much. Ephraim, Judge, have you gotten the explanation? Is it okay now? Is it cleared? Are we cleared? Are we done writing? Let's proceed to the next question. Raise, you are done. Okay, Grace, you are done. Yes. Okay, Victory, you are done. Ephraim George, you are done. Okay, Mariah, you are done. All right. So let's proceed to the next question. Okay, Maria, whether we have different voltmeter, it's not voltmeter. The first one is voltameter. And I explained yesterday that a voltameter is a device for studying the flow of current. Okay? Voltameter is a device for studying the flow of current, while voltmeter is an instrument or a device too for studying the potential difference across a circuit. So they have different, they are not the same, they have different functions. All right, if you are just joining us, just double tap on your screen and copy your question. Let's solve. Yes, it's constant. Okay? The CEC of copper is always constant. Are we done writing? Are we done writing? Please, if you are just joining us, double tap on the screen. If you are done, let's move into the explanation. One second, okay? Joe, you are just joining us. Okay, you're welcome. Okay, Grace, you're done. Fiona, are you done? Pedro, are you done? Okay, let me explain. I will give you time to still copy. Now look at this question. This question is different from what you have been solving. I'm just bringing out different ways in which they can ask you question on electrolysis. So anywhere you see it, you can comfortably solve. Now let's look at it. Copper of thickness D is placed on the cathode of a copper voltameter. Okay, let me go again. Copper of thickness D is placed on the cathode of a copper voltameter if the surface area of the cathode is 60 centimeters square. If the surface area of the cathode is 60 centimeters square and a steady current of 5.0 amperes is maintained in the voltmeter for 1 hour, calculate the value of D. Now, they give us the density of copper to be 8.9 times 10 raised to power 3 kilograms per meter cube, and they give us electrochemical equivalent of copper to be 3.3 times 10 raised to power minus 7 kilograms per coulombs. Now, looking at this question, they say a copper of thickness D. From what we have, I want to derive something. I've done that yesterday, but I want to go back. I want to recap from yesterday's class. From Faraday's first law, we have that M is equal to ZIT, right? And I said, what if we don't have what? Mass. What do? You still remember that density is equal to mass over volume, but density is equal to mass over volume, right? Now, if I want to get mass, I will say cross multiply. Therefore, mass is equal to density volume, right? Now, you must not forget that volume is equal to area times thickness. So, volume, you know that it is length times breadth times height. So, but in case you are given area, because I'm giving area in this question, this stands for area and this stands for what? Thickness. So if I replace it with here, I will have that my mass is equal to density times area times thickness. And this will be equal to the electrochemical equivalent multiplied by the current and multiplied by the time. I hope you understand. So it's going to be rho AD is equal to ZIT. And what you're looking for in this question is to solve for to solve for the thickness, which is D. Do we understand? This was the derivation we did yesterday on electrolysis. Now, this is what you're going to use to solve this problem. Is that okay? All right. I don't know if you wish to copy because I want to clean it and solve the main question. Yes, that is the unit of electrochemical equivalent. That is mass per coulombs. Do you wish to write? I want to clean the board and solve the problem. Please, I need your response. Victor, are you there? Grace, are you there? Put it down. Let's solve the question. Okay, Petra, I can clean the board, okay? to be able to solve this, let us set our parameters and get into solving. Now, the thickness is what we are looking for, okay? Then the surface area, which is given as 60 centimeters squared. Now, there is something I want you to understand. We are going to convert this centimeter square to meter square, okay? So how do we do that? You remember that if you want to convert centimeter to meter, you're going to divide by what? By 100, okay? But this one is centimeter square. That means that this is centimeter multiplied by another centimeter, okay? So I'm going to divide this by 100 and divide this by 100. All together, I'm going to divide this 60 by 10,000. Is it clear? All right, so let's go. Let's go. You divide by 10,000 with your calculator. I will say 60 divided by 10,000. I have 6 times 10 raised to the power of -3. It will not be meter squared. Is that okay? All right. Then I was given current of 5 amperes. That is I is equals to 5.0, which is something as 5 amperes. And time is given as 1 hour. Now you have to convert this hour to seconds, okay? Then we have 60 minutes make 1 hour, okay? Then for us to convert that minutes to seconds, we also multiply by 60. So 1 hour is equals to 60 minutes times 60 seconds, which will give me 3,600 seconds, right? Okay, so I have my density, and I have my electrochemical equivalent as this. So let's get into work. The formula we are going to use to solve this problem is what I just derived. So if you say that M is equal to ZIT, right? If M is equal to ZIT, now we don't have mass. The mass is equal to density, area, and thickness is equal to ZIT, right? Now, because I want to make this the subject, I divide both sides by what? Density, area. Density, area. This cancels this, right? So I'm left with what? D is equals to ZIT all over density, area. Okay? So let's get into work and multiply what we have. What is my electrochemical equivalent? That is 3.3 times 10 to the power of what? -7. Oh, okay, Grace. You say why I converted to seconds now? All right. I converted to seconds now because I have just one time. Okay? I have just one time. I was given just one time and I have to convert to seconds. But the previous one that I did not convert to seconds, I have two different time given. And I was actually doing a comparison, comparing this one with the other one. So the hour there is going to cancel each other. Okay? The hour there is going to cancel each other. So it has no effect on when you have just one time. If you're given only once, I have to convert to seconds. But that nature of question is comparison, because the question it has the same electrochemical equivalent. So we are actually comparing it and another one. So that was why I did not convert to seconds. I don't know if you are cleared. Okay. Pedro said amperes are coulombs per second. So you have to convert to match the units. Amperes are coulomb per second. No. That is not even why. I said the previous question I solved, I was comparing. Maybe after this one, I'm going to revisit that question and explain it more. I was comparing two different things. It's just like when you're solving a progressive wave equation, you're comparing. So when you're comparing and the units are the same, you don't need to convert, because even if you convert, it's still going to give you the same thing. So that was why I did not convert. Okay, so I just use it that way to solve my problem. I don't know if you understand now. Okay, now you understand. Okay, so if you are not solving that kind of question, you must convert time to seconds. Okay, now apart from that other question that you solve, all this one that we have been solving, our time has been in seconds. But when you are doing comparison, you can, and if the units are the same, you don't need to convert. For example, if the first time given is in hour and the second time given is in seconds, so you must convert to be in this of the same unit. You understand? So that was why I left it like that. All right. Agiken, you say what is I equals SA? It's not X, it's 5. This current is equals to 5 amperes, okay? That was what we have on the board. Current is equals to 5 amperes. Okay. Okay, let's proceed with the solving. My Z is 3.3 times 10 to the power minus 7 times. My current is 5. I will say 5 times. My time is 3,600. So I will say 3,600, okay? Divided by my density given is 8.9 times 10 raised power of what? 3. Then times my area, which I obtained to be 6 times 10 raised power what? Minus 3. Okay? So what I'm going to do now is to solve the numerator and the denominator. Okay. The last ECE was 3.3. Yes. 3.3 times 10 raised to the power minus 7 is a constant. Electrochemical equivalent of copper is a constant, okay? That is 3.3 times 10 raised to the power minus 7 kilograms per coulomb. Do you understand? Victory, do you understand? All right. So let's proceed with our solving. Okay, so multiply the numerator by saying 3.3 exponent minus 7 times 5 times 3,600. So we have 5.94 times 10 raised to the power of what? Minus 3. Then divided by, this is 8.9 exponent 3 times 6 exponent minus 3. Okay? I have 53.4. So I'm going to divide by saying 5.94 exponent minus 3, okay, divided by 53.4. So my answer is 1.11 times 10 raised to the power of what? Minus 4 meters. Okay? All right. So let's look at it. So I have 1.11 times 10 raised to the minus 4 meters. This is in what? In meters. You can choose to convert it to centimeter. You can convert to centimeter by multiplying by 100 if you want to, okay? Do we have question? So my G is equals to 1.11 times 10 raised to the power of minus 4 meters. Okay? All right. Okay, so if you understand, you can put it down. Let's try some questions. I'll give you classwork. Let me see whether you are following me at all. So copy down. When you are done, let me know. All right. Copy it. Let's try one or two to be sure you understood what we did today. Ephraim George, you got 0.0054. Check it again. Work on your powers. Once you make mistake on your powers, you're going to get a different thing, okay? Work on your powers and see if you're going to get the same as what I got on the board, okay? And make sure that your calculator is in degrees. Please copy fast. Let's do classwork. If you are done, you let me know. Joy, you are done, okay. Grace, are you done? If you are just joining on, double tap on your screen and give it a thumbs up. Charity done? Ephraim George, are you done? Have you gotten the answer? Maria done? Agiken done? Oh, Grace, you are done. All right. So we can proceed. Let me give you the one you are going to try for me. Let's see how it goes. Okay, this is your classwork, so you can use the same method of what I just did the last one and try it, okay? Let's get your answer. Obonaya, I should explain more on that question that you said you compare the given time. Okay, I will do that after this classwork. After solving this classwork, I will do that, okay, before we close for today, right? All right. So just solve what you have on the board. Let me get your answer. Send in your answers, okay? So get to work. Okay. Sorry, that's a mistake. Supposed to be power two. Okay, that's okay. All right. Thank you for that. Bridget, you're welcome. You just joined. Please double tap on your screen. You have classwork on the board. See if you can attempt it. Thank you for coming. Found 3 times 10 raised to power 4 times 10 raised to power 3 seconds. Okay, is that your answer? Seconds. Are you sure it's seconds? All right, we'll find out. Let's see. Okay, you meant minutes. Okay, 4 times 10 raised to power 3 minutes. Okay. All right, so let's wait for the rest. Please send in your answers. Let's get to work. Grace, are you done? Agiken done? Obonna done? Ephraim George done? Victor, writing is not clear. It's absolutely clear. I shall know from network. The density to meters. Well, do I need to answer your question now? You have to try, then I'll solve. You have to try, then I'll solve. You have to look at, let me give you a clue. You have to look at all the units you have. If they are the same, you don't need to convert. If they are the same, you don't need to convert. But if they are not the same, there is need for you to convert. Okay? If they are not the same, there is need for you to convert. So it will have the same unit. You can get the accurate answer. Agiken done. Ephraim George done. Victory, can you see it clearly now? Maybe you should change your location. Your position rather. Yes. Are we done? All right. Okay, is that we should solve. This question is similar to the last one. It's just for you to actually look for your time and then convert it to minutes by dividing it by 60. Okay, Grace. 2.4 times 10 to the power of 4. You did not tell us whether it's minutes or, okay, let's see. Minutes, ma. Can I see your values again? Let me see your values. Your answers. Okay, 2.4 times 10 to the power of 5 minutes. Okay, that's Agiken. My answer is 2.4 times 10 raised to the power 5 minutes. Okay, yes, that's a good one. Let's try and see who is correct. All right, let me solve. Okay, Obonaya, you have 480 minutes. Okay, all right. So Grace, you have 2.4 times 10 raised to the power of 3 minutes. Okay, that's a good one. So let's try and see who is correct. Now let's go. Calculate the time in minutes required to electroplate an article of area 300 centimeters square with a layer of copper 0.06 centimeter thick. That should be the thickness, okay? If a constant current of 2 amperes is maintained, assume that the density of copper is 8.8 grams per centimeter cube, and that one column liberates 0.00033 grams of copper. There is one thing you must note in this question. Look at our parameters. Our parameters are the same. You don't even need to convert. That is one clue. Our parameters are the same. Look at the area. Area is centimeter cube. Area is centimeter cube. Okay. And current is 2 amperes. Then density is 8.8 grams per coulombs. And the electrochemical equivalent is 0.0033 grams. Is that okay? All right, let's solve. Okay, Naya, you said 8 minutes. No problem. Let's just solve, okay? Charity Kalio, you have retracted your own. All right, let's solve. So we're looking for T, that is unknown, okay? My area is 300 centimeters square, okay? Then my thickness is 0.06 centimeter, all right? Then I have a current of 2 amperes, right? And the density is giving us 8.8 grams per centimeter cube. Then my electrochemical equivalent is 3.3 times 10 raised to the power of -4 grams per coulomb. Now, look at this. The area is centimeter square. The thickness is centimeter. The density is gram per centimeter cube. So we don't need to convert. Let's assume this thickness is in meter and the area is in centimeter. We must convert so that all of them will be in the same unit before we solve. Okay? Now, since we are looking for time, we are going to remember to use M is equals to ZIT, right? Now, my M is also equals to density area thickness is equal to ZIT, right? And we're looking for time in minutes. So let's first solve for the time in seconds before we cannot convert the time in seconds to be in minutes. Okay? So if I'm looking for time, I divide both sides by what? ZI. Okay? ZI. This cancels this. So my time is equal to log AD all over ZI. Right? Okay. So I'm going to substitute the value by saying my T is equal to, my density is 8.8 times my area is 300 times my thickness is 0.06. Okay, so I divide by my electrochemical equivalent is 3.3 times 10 raised to power minus 4 times my current is what? 2. Okay? So what I'm going to do is to multiply to see what I have. Let me multiply the numerator first. I have 8.8 times 300 times 0.06. So I have 158.4. Okay? Divided by 3.3 exponent minus 4 times 2. I'll have 6.6 times 10 raised to the power of minus 4. Okay? So if I divide it, 1.58.4 divided by 6.6 exponent minus 4. So I'll have 240000. Okay? That is 2.4. This is seconds. This is seconds. But the question says we should calculate the time in minutes. So for us to convert it to minutes, I'm going to divide by 60. So my T is equal to 24000 divided by what? 60. I'll divide by 60, and my answer is equal to 400 minutes. Do you understand what I did? All right. The first thing I said is that you don't need to convert. This is already in centimeter square. This is centimeter. This is centimeter per cube. So we don't need to convert. I say you convert if the parameters changes. Let's assume this is given in meters, or this is given in meter square, and while this is left in centimeter. There is need for you to convert. But this question is straightforward. So what you are going to do is to set our parameters. That M is equal to ZIT. Now, we are going to say that this M is also equal to density times area times thickness is equal to ZIT. Now, making time the subject, I have this. We are going to substitute what we have to get 240,000 seconds, okay? Because I want to make it to be in minutes, I will divide by 60 to get 4,000 minutes. Is that okay? All right. Okay, I said 1.5 instead of 158.4. Okay, that was an oversight. Okay, let me do it again. I have 158.4 divided by 6.6 exponent minus 4. Okay, yeah, that was an oversight. I got 240,000. Okay, but by the time you divide it by 6, you're going to minutes, which is the same thing as 4 times 10 raised to power 3 what? Minutes. All right. Great, you understand? Ephraim George, are you cleared? Obonna, are you cleared? Please, I need your response. Are you cleared? Agiken, are you cleared? Okay, I will give you a similar question as the assignment, Ephraim George, okay? So you can try it, okay? Now, if you are done writing, okay, so when I press my calculator, I got 40,000 minutes. No, you cannot get 40,000 minutes. is 4,000 minutes. So you have to check your answer again, okay? Okay, Ken, you understood, okay? All right. So you have to check your answer again to confirm. Most of the times, if you are raising it to power and you make a mistake, you can actually change your answer with a power of 1, okay? So it's possible it can happen. So you have to recheck what you solved, then okay, Grace say made in error. Grace, you have to recheck your work and know how to raise it to power so that I don't have a difference of 0 or a difference of 10 from the correct answer, okay? Once you make mistake on your power, it will affect your work entirely. So you have to be careful with that. All right, I think we are done. All right, so let me revisit that question I said that when you are doing comparison, you don't need to convert, okay? So that you all be cleared. All right, so that you understand when you see such a question. When I'm done with that, then I'll give you class assignment that I will solve tomorrow when we meet again. All right. All right, I was trying to tell you that when you are comparing two things from that particular question, we are given the first current, the first time, and the first what? Mass. Now, we are also given the second current, the second time, and we are asked to find what? The second mass. This is what I mean by comparison. If you remember that M is equals to ZIT, okay? So when you are comparing, you divide both sides by what? IT. This cancel this. So my Z is equals to M over IT. When you are comparing two things, that means M1 over I1 T1 is equals to M2 over I2 T2. Do you understand? So with that being said, and I said, in this type of question, you look at your unit. Like they give us time, the first time in hour, the second time in hour, and I did not convert. Why didn't I convert? Because I'm doing comparison. And compare this. Time is given in hour and the second one is given in seconds. I can't solve like that. I must make sure that the units are the same by converting. It's either I choose to convert it to minutes, to seconds rather, or I will convert the seconds to hours to be able to meet up the other one. That is what I mean by when I'm doing comparison. So because the two time, T1 and T2, are both given in hours, so there is no point converting it because the hour is still going to cancel the hour. Do you understand my point now? So, but aside from this, all time must be in seconds. In each time you are giving time, you must convert it to what? Seconds. Do you understand? Are we all clear? All right. All right. Grace, do you understand? Ephraim George, are we cleared? Ephraim George, do you understand? Okay. Okay, from Joy, you got it. Okay. So let me give you an assignment for today. So I'm going to solve it tomorrow before we proceed with tomorrow's class. All right, please, can you copy the question? All right. Can we copy the question? Grace, it's not clear. Can you see it clearly now? Is it clear now? Okay. Okay, Ken, done. Okay. Grace, are you done? Victory, done. Ephraim George, done. Okay, done. Okay. Ephraim done. John, Ephraim George, done. Okay. All right, so I'm going to end this class right now. Thank you so much for coming. I really appreciate. So make sure you do your homework. Okay, do your assignments rather. Okay. So the more you solve, the more you understand physics better. Tomorrow I'm going to do the assignment. I will compare if we are actually correct. All right. See you next time in the next one. Bye.